Hello, my name is Preethi, TRB Triple Padikalam Vanga. Wishing you a happy and prosperous new year. And today we are going to see a set of 4 questions based upon the basic circuit laws. Yeah. The first question, theorems applicable for both linear and non-linear circuits is. So the 4 different options are given to you. Before going to solve this problem, we need to understand the basic key points like the superposition theorem, Thevenin's theorem, Norton theorem, maximum power transfer theorem are all applicable only for the linear circuits. Whereas in the case of Telegon, Tellegen, Telegon and the theorems like substitution theorem are applicable for both linear and non-linear circuits. So these two theorems we can able to choose it, but our options are superposition, Thevenin's, Norton's and none of these. So our option is none of these. For both means we can choose these two theorems. Okay. The next question, a practical current source is usually represented by dash. So normally a practical current source is equivalent to one ideal current source in parallel with a high resistance. Am I right? So we'll be having a ideal current source. It is in parallel with a high resistance. Otherwise we can say it as low conductance. So in this way we need to represent. When you take the case like a practical voltage source means it consists of an ideal voltage source in series with a internal resistance. Am I right? So a practical current source means we can take the option as a resistance in parallel with ideal current source. A resistance in parallel with ideal current source. So please have this concept. Yeah. Okay. And the third question given you as the voltage VAB in the figure will be. It is the question they have been asked. So how we are going to solve this problem? Before solve this, we should know the concept of the polarity of the voltage. Let us assign the plus and minus symbols here. Yeah. Our question is finding out the voltage VAB. So let us have the simplified circuit diagram from A to B. So we'll be having minus, plus, and we'll be having plus, minus, and then minus, plus. Am I right? This is A and this point is called as B. And they have given you as 5 volt and 3 volt and 1 volt. So minus, plus, plus, minus, minus, plus. Now tell me, so minus to plus means we can have VAB is equal to minus 5 volt and then here plus to minus. So we can have plus 3 volt and minus to plus. So we can have minus 1 volt. So now adding all the 3 voltages, minus 5 plus 3 gives you minus 2. Minus 2 minus 1 gives you minus 3 volt. So VAB, the voltage will be minus 3 volt. The next one, the fourth question, on considering the principle of duality, which of the following pair is invalid dual pair? They have given you the 4 different options. Before going to solve this, we need to understand some important dual relations. Nothing but resistance means we can take conductance and inductance means we can take capacitance. Resistance means conductance, inductance means capacitance. A series branch means we have to move on to the parallel branch, and mesh means node. Sorry. The switch closed means switch open. Charge means flux linkage. Voltage source means current source. Link means twig. Star network means delta. Pi network means T network. Impedance means admittance. Okay. We need to understand the following elements and dual elements. But here we can take resistance and conductance. Yeah, it is correct. It's the element and dual element. Yeah. The next one, impedance means The dual property element is admittance, not this pair. The pair is incorrect. Voltage and current, yeah, it is correct. Inductance and capacitance, yeah, it is correct. So invalid dual pair is impedance and reactance. But the correct one is impedance and admittance. Okay. Please like, share and subscribe, my dear friends. Thank you, and thank you for your support.